I'm Shamish Kadam. The topic for my today's presentation is implementation of multi-channel GPS receiver baseband modules, and the authors are Kota Solomon Raju, Y. Pratap, Virender Patel, Gaurav Kumar, S.M.M. Naidu, Amit Patwardhan, Rabinder Hendry, and P. Bhanu Prasad. So the GPS is a satellite-based navigation system which is satellites revolve around the earth, and it detects the position or the of the object. It was started in 1973, and applications of the GPS are to navigation, surveying. Also, it is used in space navigations, in automatic vehicle monitoring, in emergency services, mapping, and geographic information system georeferencing. Then GPS works in 32 satellites. That 32 satellite out of those 32, 24 satellites are currently divided into 6 orbits, and each orbit has 4 satellites. Each of these orbits make an inclination angle of 55 degree with Earth's equator. Each of these orbits are separated from each other by 60 degrees, thus completing the 360 degree of whole Earth. Each satellite rotates around Earth 2 times in a day, and it has approximately radius of 26,550 kilometers. The GPS signal structure. The GPS satellite transmits the signal, and it is received by the antenna of the GPS receivers. The GPS signals are transmitted on two radio frequencies in the ultra high frequency band, which are L1 and L2, and are commonly derived from a frequency of 10.23 megahertz frequency. GPS signal consists of mainly 4 components: course acquisition code, navigation data, carrier frequency, and Doppler frequency shift. The digital multi-channel GPS receivers is the once the signal is captured by the antenna of a GPS receiver through the radio frequency chain, the input signal is amplified to a proper amplitude, and the frequency is converted to desired frequency. And this is signal is again converted into digital through analog to digital converter. Once the digital signal is obtained, it is down converted to a required intermediate frequency, which is 17 megahertz. Then the IF is then sent to the first digital baseband module, that is acquisition module, which is seen in this figure. The acquisition module helps in finding out which satellite is in this signal is coming from, and the tracking module helps in finding out the phase transition of the navigation data. The navigation data gives us information of the orbit of the satellite. From the navigation module, we obtain the pseudo range and ephemeris data, and this from which we obtains the satellite's position, and this satellite's position gives the user's position. Acquisition module. The main purpose of the acquisition module is to determine visible satellites and course values of the carrier frequency and code phase of the satellite signals. There are mainly 3 algorithms used in the acquisition module: serial search, parallel frequency space search, and parallel code phase search. The parallel code phase search acquisition algorithm is to perform correlation with the incoming signal and a PRN, pseudo random noise code. The figure shows the parallel code phase acquisition algorithm. Then the tracking. The main purpose of tracking is to refine the course values of the code phase and the frequency, and to keep track of these as the signals property changes over time. It demodulates the incoming signal to obtain the 50 Hz navigation data signal. The tracking mainly consists of 2 parts. One is code tracking DLL, and second one is carrier tracking PLL. The figure explains the complete tracking module. The code tracking. The code tracking loop used in GPS receivers is a DLL, which is delay lock loop, is also called an early minus late tracking loop. The main purpose of code tracking loop is to keep the track of the code phase of a specific code in the signal. The output of the code tracking loop is a perfectly aligned replica of the code. The reason to use DLL is to correlate the input signal with three replicas of the code, which are early, late, and prompt. The implementation of GPS receivers on Leartec SFF SDR board. The SFF SDR board is conceived and designed to be used in the development of application in the field of software-defined radio. The board is composed of three different platforms: digital processing module, ADAC master 3, and RF module. As the signal receives at antenna, it is transmitted to RF module, and then RF module takes the signal to data conversion module, and from there it is taken to signal processing module, and through Ethernet it was gone to PC Simulink module. The results and future works are: it is able to generate 17 megahertz intermediate frequency required for our board, and after generating infrared intermediate frequency, the next task is to implement the acquisition and tracking module. The conclusion is this implementation will lead to the development of indigenous GPS receivers with single and multi-channels within the same hardware with reconfiguration. And these are the references. Thank you.